Okay, so hi, welcome to our Pink Panthers ASL Translator presentation. I'm Cullen. I'm an upcoming sophomore at Hopkinton High School, and I like to play video games and learn new things. And for this project, I worked on the back end of the HTML and CSS, and also the collection of the data.
Okay, so hi, I'm Dasha. I'm a student at Bronx Science, and I have a 178-day Duolingo streak.
Hi, I'm Henry Zhou. I'm a rising junior at Pineview School. I love robotics, and in this project, I worked on creating and training our AI model and developing this website.
Hi, I'm Timothy, and I'm now a sophomore at Science-Based High School. I hope with making the front end part of the website and training our AI model. I also like playing video games in my spare time.
Hello, I'm Raphael. I'm a freshman at Roland Hall. I work mainly on front end and annotating images. I also like skiing.
Hello, I'm Roy, and I'm a rising sophomore at St. Mary's High School. I worked on the front end of the website and helped with collecting and annotating the data.
And our team leader was Prasanga Neupane, the GOAT. Okay, so we're the Pink Panthers. That's why our website is pink. We really took that name to heart. We completed an American Sign Language translator project. Our project has 3 key features: a still photo object detection, which can detect 26 characters of the ASL alphabet in a still photo, and that's going to be demoed by Henry, and the live video detection, which can detect the same characters, but in a live video feed, which will be demoed by Cullan. And in the live video feed, there's also an audio that reads out the letter as you say it. And this can be really helpful for mute users and users that are using AI to learn sign language.
My project, known as the ASL Translator, recognizes different letters from an ASL alphabet, which allows us to translate the letters of the text into English. This translator uses YOLO v5, a neural network which can detect objects to photos or real-time camera feeds. Using YOLO v5, we trained our models to recognize all the letters in the ASL alphabet. So our motivation for this project is many deaf and mute people rely on sign language to communicate. However, many Americans don't know ASL and cannot communicate with the deaf community. We wanted to create an ASL translator which could work in real time to help break down this language barrier, and also have our translator be beyond any translators we have seen in the past. This is why we have created the ultimate ASL translator.
Okay, so these are the technologies we used for the product. First, we used Python for coding the project, and we used RoboFlow for annotating the data. Then we used Google Colab to train the model. We used YOLO v5 for real-time object detection. For the website, we used HTML, CSS, and Bootstrap. We also used CodeCalc as the workspace for collaboration within the team.
Before starting, we had to decide on a project. At first, we started a project that read sheet music and played the notes, but because the AI could not read the sheet music and differentiate between the notes on the staff, we had to switch the project. After that, we went right to the ASL project because just from labeling the images, that was easier. Gathering the data is a step that is vital for a good algorithm. No matter how good the model is that we're training, if the data is faulty, then it's not going to recognize it correctly. Luckily for us, we found a data set with around 1,500 images, to which we add roughly 1,000 more of our own. Using the images we took images with our hands in front of our faces so that the algorithm could distinguish between the two. Training our model. Before training our model, we did something called data augmentation, which means that we added pixels to the 2,500 images we had, or added contrast, or like applied grayscale. That means that from one image, we could make many more. Overall, we had about 5,000 images at the end. And last but not least, creating our website. Once we had a trained model with all its features, we needed a website that showcased the AI and explained what it did. We uploaded a template from Bootstrap and downloaded it to CoCalc. We used CoCalc to collaborate with our code and with each other. We edited the template with HTML and added the information. Then we used CSS for colors, speed, and format. And this is the final product.
And for the video, Roy, do you want to talk about that?
Yeah, sure. Okay, you see Cullan trying to test our trained ASL model over the video feed.
It's pretty cool.
Yeah, you can see he's doing some ASL signs, and this model is able to recognize these letters.
All right, now time for a demonstration of the still photos function. First, just upload a photo, any photo, preferably JPEGs or PNGs, and I'll upload one here. And great, our AI model detected an eye, which this is the correct symbol for an eye in ASL sign language, and it's a 95% confidence. We try another photo, such as a random photo from the internet. It has K, 92% confidence. And another photo would be S. Great, so the AI found the S with 95% confidence. And
How
for
does
our
it tell
final,
the difference between I and J?
that is a little bit tricky. We used a lot of training data to differentiate the I and J. There is J is a little bit slanted, so it does detect. It. Here, I could show you one we used. So earlier it detected I, and now it detects J. 95% confidence. You can also upload a photo without any sign language. And an example, the AI model should find none, which is none of the 26 alphabetical classes that we labeled. So we still have some errors in our model. That's because we only had less than 2 weeks to work on the model and train it. We only have around 3,000 labeled data. If we had more time, we could add more data to make it more accurate. And our results are displayed in this confusion matrix. As you can see, 1 is the highest value. It's the highest value for accuracy. So many of our letters actually received a 1, which is great. But some of the letters were confused by the AI model. As you can see, there's V and W. And those are not as distinct as other letters. And the background false positives, well, there were a few errors there. This background false positive, it means that if you upload a photo without sign language, then the model will detect sign language, even though there isn't any in the photo. Just like this photo, for example. It could detect an O or a V, and those would be background false positives. And to fix that, if we had more time, we could add more data of background images and void them out by making them null data. So the model will detect its background image. And if you have any questions about our product, please contact us. Now I will pass on the power of screen share to my colleague Cullan for his video demonstration.
Thank you, Henry. So at first, in the creation of this website, we had an issue with transferring images from the JavaScript to our actual Flask app. So I'm going to be running it on my local computer, and I'll share that. Okay, so here it is. I have like terminal in the background that you can't see, but I'm going to try it out. Okay, so that's me. I'm gonna do like a couple of letters for you. So I'll do C.
C.
I think you can hear it.
O.
O. We can do like W.
N. W.
And sometimes it's gonna get it wrong. This I. Sometimes it's gonna get wrong from like the translate or the transition between like an O to a C because it's not used to being on video, but that's basically our demo.
Yeah, our data mainly consisted of images, not live feed, so it would get confused with the transitions. And that's our presentation. Thank you, guys.